For our next integration by parts example, we have something that's a little bit more involved. We've got the antiderivative of x minus 5 times e to the 7x power times dx. Once again, I can tell that this is going to be an integration by parts example because I'm multiplying two different kinds of functions. I've got this x minus 5, which is a polynomial, or if you want to think about it as a power function. And then over here, I've got this e to the 7x power, which is an exponential function. So you can try and use substitution if you'd like. It's unfortunately not going to work out for us. So I need to, if I recognize this is an integration by parts problem, I need to first of all decide what's going to be my u and what's going to be my dv. And I can scroll back up here just in case we need a refresher. We said u should be the first thing that's on this list, which the best choice is a logarithm. And if I scroll back down here, well, we don't have a logarithm. We said we had a polynomial, and then we have an exponential. So we don't have a logarithm, which that means we move on to our next choice, which would be that polynomial or power function. So scrolling back down, we're going to take u to be that polynomial, the whole factor of x minus 5. So u is x minus 5. And that means that dv is going to be everything that's left over. So dv is going to be e to the 7x power dx. So I've made my choice for u and dv. My next step would be, okay, well, we need to go and find du, and we need to go and find v. So du, the derivative of x minus 5, derivative of x, that's just going to be 1 times dx. And then over here, what makes this one a little bit more involved, I know that I need to integrate dv to end up with v. So I'm going to be integrating both sides here. But what makes this problem perhaps a little bit more challenging is I've got this 7x. It's not just e to the x power, it's e to the 7x power, which means I have to use substitution. So I'm actually going to have to do even more scratch work over here. That's okay, we'll take our time. Normally, for substitution problems, I would choose u as my substitution variable, but I've already got a u right here. I don't really want to choose another one, so I need perhaps a second u. Perhaps I would call it something like w? I'm sorry, I couldn't help myself. But we're going to choose w to be this power right here, 7x. So w will be 7x, which means that the differential dw will be the derivative of that 7 times dx. And if I want to make my substitution, I'm not quite ready to find v yet. I've got a little bit of work to do here, so this is still going to be dv. I see this part right here is my w, which means that dx is the only thing that's left over. I have just dx right here. I'm going to have to multiply both sides of this equation over here by 1 over 7. Doing that gives me 1 over 7 times dw is equal to dx. So there we go. That means that when I substitute out this dx right here, I'm going to have to substitute it for 1 over 7 times dw. So dv, again, remembering we're actually integrating this function. I'm going to integrate, instead of e to the 7x, we're going to do e to the w times, we said, instead of dx, 1 over 7 times dw. I'm going to go ahead right away before I actually integrate. I'm going to factor this 1 over 7 out just because I don't want to make a silly mistake and, forget to do something with it. So I'm going to factor that out. So dv, we're still integrating here, is 1 over 7 times the antiderivative of e to the w dw. And we finally have this right-hand side over here as one of those basic elementary antiderivatives that we know and love. So the antiderivative of dv, or 1 times dv, that left-hand side gets us v, which is what we wanted. 1 over 7 is a constant multiple, so that comes down. 1 over 7 times the antiderivative of e to the w is e to the w power. And then finally, my last step is, okay, we can go ahead and take our w, which is 7x, plug that back in. So v is equal to 1 over 7 times e to the 7x power. Okay. At this point, now we have everything that we need, because we have our u, we have our du, we have our v, and then of course our dv up there as well. So we should have everything we need for our integration by parts formula. So let's go ahead and write that down just so that we have something to start with. We've got u times v minus the antiderivative of, actually, let me scroll back up. I am having a brain fart here. V times du. Even I need to look it up from time to time. V times du right here. So, okay, u, what was u? U, we said, was x minus 5. So we've got x minus 5 times v. So times, we'll do that part in red, 1 over 7 e to the 7x power minus the antiderivative of v times du. V is 1 over 7 e to the 7x power times du. What did we say du was? Well, du was 1 times dx, or if we want to simplify it as just dx. So, okay, here's where we're at. This big left-hand term over here, I'm just going to leave it for now. Maybe we'll move that 1 over 7 to the front. 1 over 7 times e to the 7x times x minus 5. I'm not going to bother distributing for reasons which will hopefully become clear in just a minute. Minus 1 over 7 right here. That's a constant multiple. Let's go ahead and factor that out. Minus 1 over 7 times the antiderivative of e to the 7x power dx. So I need to, at this point, evaluate this antiderivative, and once I have that, I should have my answer. Now, I'm going to run into a slight problem here again because of this 7x again. I need to use substitution, but if you'll notice, hey, I want to integrate e to the 7x power dx. Well, shoot, that was what we did up here. We did that up here with that e to the 7x power dx, way the heck up here. So we know that when we integrated e to the 7x power dx, again, I'm looking at this part right here, is identical to what I'm trying to integrate down here. So I know that when I integrated that, I ended up with this v 1 over 7 times e to the 7x. We do not need to reinvent the wheel here. We can use the work that we've already done. So I know that my antiderivative is going to be the same as this part right here. So let's bring that work down and plug it in. 1 over 7 times e to the 7x power times x minus 5 minus 1 over 7. That's coming from this part right here. Times the antiderivative, which is this part. I'm going to go ahead and plug that in right here. So that should be 1 over 7 times e to the 7x power, and of course we can't forget about our plus c. After this is just a matter of simplifying this, cleaning it up however you'd like to do that. Let's go ahead and multiply this out. So this is 1 over 7 times e to the 7x power times x minus 5 minus, that's 1 over 49 times e to the 7x power plus c. Beyond that, if you'd want to simplify that further, we certainly could. We could, for example, if we wanted to factor out this e to the 7x from both of these two terms, we could also factor out 1 over 7 if we really wanted to, but I'm going to go ahead and leave it right there. I'm not expecting you to simplify it beyond something like this, where we go ahead and multiply any common factors that we can. And then that seems like a good place to stop. So